At crucial moments, we see some men, some women sleeping. That's cool. But something interesting that I want you guys to know is that at such time, heroes are known to be awake, planning and executing plans to succeed. This is GMAETS 41. You are welcome to this part 3, the last part of our Math 101 exam revision. Already on this channel, part 1 and part 2 of these epic super showdown revisions have been made available. It becomes very necessary that I conclude with part 3. And although I do not owe anybody complete apology per se, but partly let me say I'm sorry because I was supposed to have held this class before now, but I made a little trip today. But then I'm back. And then I decided to showcase the strength of being a hero. So if you're connected to this class right now, you are a hero. Share the link to this live class to your departmental WhatsApp group, to your friends directly, and tell them to join this class right now. We are going to do revisions on some aspects of your Math 101, which were not covered in part 1 and part 2. And make no mistakes, some of you will see these questions in your examination later, because it's already approaching midnight morning, you know. So once again, you're welcome. First, we are going to look at the concept of trigonometry. Trigonometry. So the first revision will be based on trigonometry. Good. After that, we hope to give attention to some part of AP and GP, that is series and sequence, and then just touch some little things on permutation and combination, because those parts were not really fully covered in part 1 and 2 revision. So without wasting time, please, let's kick off. As we revise this part 3 of your Math 101, trigonometry, there are some things I would like you to know. I'll be checking the network situation, okay, on and off, so that I'll be sure that you are following and you've not been disconnected. Are you getting me right? Good. So we've got our very first question, but before then, there are certain things I would like you to know about your trigonometric problems, because there are areas in trig that you are usually being tested on in Math 101. And so what are the things I'd like you to know? Certain formulas, basic trig functions. I won't bother you on that. I want to believe that by now, all of you, yes, all of you, if you've been serious on following your studies and or GMAS for the one's work, should have known the basic trig functions. Sin theta is opposite of hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over what? Adjacent. Now, there are certain things I'd like you to know. One of them is your Pythagorean identity. There are 3 of these Pythagorean identity. I would write them on the board. Quickly, you want to recall the following things: that square sin theta plus square cos theta is equal to 1. Is equal to 1. Things you want to recall. Good. So you take note of this formula, please. Under trig, you need it. You need it. Now, if you divide each of these terms, if you divide each of them by square sin theta, that is, divide each of these 3 terms. We have 3 terms here, 1, 2, 3. Divide each of them by square sin theta. Divided by square sin theta, what would we get? 1. Divided by square sin theta. You know that cos over sine is equal to cot. I repeat, cos over sine is equal to cot. Because cos over sine will give you tan. So if you inverse it, you get cot. Which means if I come here and I divide this square cos theta by square sin theta, I am going to get square cot theta. Square cot theta. And then come over here and divide this by square sin theta. You know that 1 over sine is cosec. So 1 over square sine will give you square cosec theta. So take note of this second Pythagorean identity. Although the first one is the most important as you're preparing for this year exam, but I just want to highlight the 3 of them once and for all before we look at 7 questions, you know, on these guys. Now, the next one you need to know is dividing each of these by cos squared theta this time around. Remember, to get this, I divided this first one by square sine theta. So if I decide to divide by square cos theta, what will I get? Come here, divide square sine theta by this square cos theta. You are going to get square tan theta. Good. Square tan theta, because sine over cos is tan. Then plus, come to this, divide this square cos theta by square cos theta. You're going to get 1, of course. And then that's equal to divide this 1 by square cos theta. Remember that 1 over cos will give you sec. 1 over cos will give you sec. So 1 over square cos will give you square sec. So square sec theta. These 3 equations on the board are called Pythagorean identities. Please take note of them, and especially the first one. Especially the first one, yes. For this exam you are going for, the first one is most important. Now, other important things you should know under trigonometry as you step into your examination in less than 10 hours from now. Yes, less than 10 hours. Because the first batch should be entering the examination hall there about 8 a.m. or so. I guess so. So another thing you want to take note of are the formulas of double angles. A sum and difference of 2 angles, rather. Sum and difference of 2 angles. So take note of them. If I give you sine A plus B, it is going to be equal to sine A cos B plus cos A sine B. You are expected to memorize these formulas. Problems can be given to you that you use them, okay? So take note of this. Let me call this question 4. Then, if I give you sine A minus B, it follows the same format, just that you're going to fix minus following the sign you have here. So this is sine A cos B minus cos A sine B. I will take this as equation 5. By the way, although this particular revision class targets Nnamdi Azikiwe University students, Unizik 100 level student, but take note please, if you are sitting for JAM and you will take maths, assuming you're taking maths in JAM, you need this. And if you're in any other school in Nigeria or in any part of the world, yes, and you're offering maths course, you still need this revision, so make sure you connect. We move on to the next identity you should be aware of. Cos A plus B is equal to this identity, cos A cos B. Then, if you have plus here in the case of cos, the sign you have here will be minus. So the sign here is opposite to what you have between these 2 angles. But that of sine, remember, that of sine, the sign that you have between the angles are the signs that you maintain here. So this is going to be minus sine A sine B. Now, I want you to take note of something. If angle A is equal to angle B, if angle A is equal to angle B, you know we can remove this B from here and fix A. We can remove B from here and fix A because they are the same thing. And then A plus A will give you 2A. I repeat, if you remove, if A is equal to B, angle A is equal to B, then in place of B in all of this equation, wherever you see B, you are going to fix your A. I think, let me give you the third one before I actually bring in this concept. Is it the third one or the fourth identity? Which, of course, is the last identity you should be aware of, while preparing for trig parts. So let me give you this. Cos A minus B will now be, to follow the same format, cos A cos B. And then since you have minus here, the sign will be plus. And then you have sine A sine B. Take note of these identities. This is number 6 and this is number 7. You observe something in sine for you to easily memorize it and remember. If you are dealing with sine of sum and difference of two angles, it's going to be sine cos, cos sine. You can see that here. You are dealing with sine of sum of 2 angles or difference of 2 angles. The arrangement is sine cos, cos sine. The sign that you use, the mathematical operation you use, they still follow exactly the way you have them in the difference or sum of the 2 angles. But if you are dealing with cos, the identity will be what? Cos cos, sine sine. Let me take a look at the network situation, please. I don't know, but this is quite confusing to me. Well, Chidebele, I don't know. I don't know. You see, that is why I always advise you, friends, and please, in as much as this does not affect me directly, because I'm not the one sitting for this exam, and I'm not the one to take it, my name will not appear there. But I feel the need to do this for students. And I always advise students, learning on time is very important. You see, this revision class is not a full teaching something. It's not a full teaching. Although I have video lessons where I derived all these things on this channel. But as it stands now, in less than 10 hours to your exam, of course, you don't need the derivation. You don't need the derivation. So permit me to please be a bit raw in what I want to say here, that you're expected to just cram these formulas I'm giving to you. When I pick questions and solve your real-time exam questions, are you following right? You see how we apply them. For now, this is what you're meant to do. Please, Chidebele, that say that for you, these things are confusing. Yes, it should confuse you. Don't panic. Memorize the identities, just like formulas. Are you getting me right? Memorize them. Okay. If I say that angle A is equal to angle B, these last four formulas will take some kind of format. They will take some kind of format. Now watch the format. Let me divide this board into two parts so that they can be contained. Come here, and then in place of B, you fix A. If you fix A, this is going to be A plus A, which is 2A. So we are going to get sine 2A to be equal to, you come here, sine A cos A plus cos A sine A. Watch, you're going to get sine A cos A, because in place of B, you have fixed A, plus cos A sine A. Now observe something here. If this is sine A cos A, and this one is cos A sine A, it means that this term and this term, they are exactly the same thing. It's just like somebody telling you add x plus x. If you add it, you're going to get 2x. So if I have sine A cos A plus cos A sine A, it's going to be twice of that sine A cos A. So this is going to give us 2 times sine A cos A. This becomes the format of equation 4. And I can call this equation 4A. Take notes. I can call it equation what? 4A. Now let us move on to the second one. Sine. Also, okay, you can't do for the second one because it is subtraction. Nothing is going to work there. It's going to be 0. So let me call this equation 4A. I got it from equation 4. Then we go to that of cos and repeat the same thing for the positive, sum of the two angles. Come over to this cos A plus B. In place of B rather, fix A. If you fix A, this will become A plus A, which is 2A. So we're talking about cos 2A. Also, cos 2A is going to be equal to, you come to this term, this is cos A times cos A. Because in place of B, you are fixing A now. So cos A times cos A is going to give you square cos A. And then minus, do same here, sine A, sine A. If you multiply sine A by sine A, you're going to get square sine A. So I'm going to call this equation 6A. Because I obtained it from equation 6. Like I said, you just have to memorize these formulas. Sorry about it, but please learn on time and learn with the right person. As long as Unizik is concerned, if you're taking extra lessons besides your lecture, GMAETS 41 is the right person to learn with. I leave you to argue that with yourself or whatever, but I've told you the truth. Let's move on. Now that we have that cos 2A is equal to square cos A minus square sine A, we can still play with this particular one, this particular square sine A. We can play with it as another identity you want to remember. If I remove square sine A and fix this Pythagorean identity, remember that if you make square sine theta, where theta in this case now is A because we are talking of angle, if you have square sine theta, make it subject of the formula, this square cos theta will go to the right hand side. What I'm saying in essence is, if I give you sine square theta as subject of the formula is going to be 1 minus square cos theta. So if this thing is square sine A, is going to be equal to 1 minus square cos A. Which means we can actually fix 1 minus square cos A. If I am using A as my angle, I can pick this 1 minus square cos A and fix it for square sine A. So work with me now. If you pick this guy, 1 minus square cos A, transfer it here, remove this square sine A, and fix that 1 minus square cos A here. You notice that this minus will affect this one. You're going to get minus 1. And this minus is going to affect this minus square cos theta, that is square cos A, to change it to plus. To change it to plus, you can do the substitution there, please, no time. Remove this square sine A and fix 1 minus square cos A. You know that theta is A. You can use any symbol to represent your angle. So it also implies that cos 2A is equal to square cos A minus 1. Then this minus will affect this minus to change to plus. So you have plus square cos A. And then this square cos A plus square cos A will give you 2 cos square A, or 2 square cos A. That's what you're going to get if you do the substitution. So everything will now be, that one is minus, so square is going to be square cos 2 square cos A, 2 square cos A, and then minus 1. That's what you're going to get there. So you take note of that. I'm going to call this equation 6b. 6b. I told you the substitution already. So if you follow it, and in place of this square sine A, you fix 1 minus square cos A. You're going to get minus 1 and then plus square cos A. And then you have this square cos A here. If you add it to the square cos A, you're going to get here, you get 2 square cos A. So these are basic identities. Yes, you are expected to know as we move on into solving 1-2 questions here. All right. So you see, you friends must do the needful. Very important. Let me adjust the camera a bit. Let me adjust it to capture all those parts. Let me adjust. If you do not know all of this, it is not ideal for you to solve problems on trigonometry. Yes, for the part of trig you guys are covering in your exam. Are you following right? Yeah. So make sure within the less than 10 hours you memorize this concept. So we are done with this. It is now time for us to solve questions. It's now time for us to solve questions. It's now time for us to solve questions. We're going to pick our very first question and solve. We're going to pick our very first question and solve. You can screenshot as you're dealing with it, so we don't have time to waste. Please take notes. In fact, I even took my time to write all these things for you. Normally in pure revision class, just like this one is, I was not meant to do that. Yes, I was not. But just to help some of us here. Look at this question. Watch out for it. Watch out for it. You may see it in your exam tomorrow. Watch out for it. So let us see what we have in that question. Let us see what we have in that question. So let me say Q1. Q1. Like I said, please don't bother yourself about understanding these formulas, these identities. Don't bother yourself. This is not time to understand them. This is time to memorize them. Given tan theta equal to 3/4 for 0 less than or equal to theta less than or equal to 90 degrees, what is the value of sine theta? What is the value of sine theta. So how do you solve this question? There are two different approaches you might decide to use and still arrive at the same answer. I'll show you one quickly. Now, from this question given to us, we know the value of tan theta. Tan theta is equal to 3 over 4. This simply means that we have this as opposite, and then we have this as adjacent. You know that tan is opposite over adjacent. So do you see that from this problem given to you, you know your opposite, you know your adjacent. You are asked to find sine theta. Sine theta is equal to opposite over hypotenuse. So your problem, my dear friends, is just for you to know the hypotenuse of the right angle triangle that this problem was extracted from, because this is a right angle triangle problem. Are you following, right? Get the value of hypotenuse. Once you know the hypotenuse, to find sine theta, so you remember so katoa, so opposite over what? Hypotenuse will give you sine theta. Now, how do you get the hypotenuse here? Simply, you use Pythagoras theorem. If you're in examination hall, you don't waste your time. You know your Pythagoras theorem by now. That is what is expected after 4 months of preparing for your examination. So, we can calculate our hypotenuse. That, let me use h as hypotenuse. H as hypotenuse is square root of opposite, and the opposite is 3 square, right? Plus square of adjacent. You know, this is Pythagoras theorem. You don't need to write out the formula. You don't need to write any grammar in the examination hall. This is CBT, and you don't have time. In fact, I got to know, the time that was given to you, friends, in your Physics 101. I've always said that you don't have time. That is why you want to be as fast as possible. You need to be well trained before you move on into your examination hall. There is no time for you to be writing formula you already know. So start substituting directly and solve. If you work out 3 square, you get 9. 4 square, you get 16. Add 16 to 9, you get 25. Square root of 25 will give you 5. So the hypotenuse is what? 5. You can now conclude, therefore, that sine theta, which is equal to opposite over hypotenuse, a waste of time, because I shouldn't write this formula. It's not necessary to write this formula if I am to be seated. Are you following? Just like you friends are going to be seated for this exam, it's no longer tomorrow, it's later, because we're already here. This is 16 after 12 a.m. in Nigeria. So for the friends that are taking this exam tomorrow, it's less than 24 hours. So you don't need to write this formula. It's not necessary. You know that sine theta is opposite of hypotenuse. So you fix. Your opposite is 3. Your hypotenuse is what? Hypotenuse is 5. So this is the value of sine theta. This is the value of sine theta. Now, if you don't want to use this approach, the choice is yours. But I don't know which one is even faster. I don't know which one is faster. It's all dependent on how well you understand this concept. That's the truth. Okay? Well, assuming that you don't want to use this approach of Pythagoras theorem directly, this problem can still be solved using another approach of Pythagorean identity. Pythagorean identity. They gave us the value of tan square theta. The value of tan square theta was given to us. So I can remember the Pythagorean identity. Remember, we started first by saying square sine theta plus square cos theta is equal to 1. And I said, okay, can we divide through by cos? If you divide through by square cos, the square sine theta over square cos theta will give you square tan theta. So I'll say, recall, we have the Pythagorean identity that square tan theta plus 1 is equal to square cos theta. So we know this Pythagorean identity. Okay. Now, if this is true, which of course it is, tan theta, we know the value here. Tan theta is 3 over 4. So in place of this tan theta, I will fix 3 over 4. But remember that the tan theta is squared. So if you're removing this tan theta to fix 3 over 4, by the way, take note, square tan theta is the same as tan theta in bracket all raised to power 2. That's the meaning of that. The same with square sine theta, square cos theta. Are you following, right? So If tan theta alone is 3 over 4, if I'm picking this 3 over 4 to fix here, I'm going to square it because this tan theta is squared. So let's do it once, no time to waste. Square the value of tan theta. The value of tan theta is 3 over 4. If you square 3, you are going to get 9. If you square 4, you're going to get 16. Then add 1 to it, make it equal to square sec theta. Make it equal to square sec theta. Now you can work out the LCM of this guy. If you work out the LCM of 9 over 16 plus 1, the fastest way of getting this LCM done, adding a fraction to a whole number, is denominator times whole number, add the numerator. 16 times 1 will give you 16. Add 9, you get 25. So this whole term is 25 over 6, over 16 rather, which means that square sec theta is equal to 25 over 16. Let me create enough space. So it implies that 25 over 16 is equal to square sec theta. And if 25 over 16 is equal to square sec theta, what will be sec theta alone? Sec theta alone would be take square root of both sides. So you watch, if you take square root of 25 over 16, what will it become? Square root of 25 over 16 is going to give you 5 over 4. 5 over 4 will now be the value of sec theta alone because I've taken the square root. Take note, your brain is meant to be delivering. You know, the network of your brain has to be sent out and deliver impulse like electrical discharge. All of these things are things you're meant to have prepared, you know, and have been coached for before this D-Day. Second semester is still there, you dear friends, to make use of GMAETS 41 to the fullest. So that during your revision like this, you just be smiling, no stress. If I say A, you already know where I'm going to. And in fact, even before revision, while you are taking your lectures, if the lecturer steps into the class, write the topic, you already know everything about the topic. Just pay attention, follow through. Are you getting me right? That's it. Now that I know that sec theta is equal to 5 over 4, remember what we are looking for is sine theta. What is the meaning of sec? Sec is 1 over cos. Sec is 1 over cos, which means that 5 over 4 is equal to 1 over cos. And if 5 over 4 is 1 over cos, you can take an inverse, turn them upside down. Take cos up, take the denominator of this one up. I can conclude that cos theta from here is equal to 4 over 5, where I have gotten my hypotenuse as 5. Remember, sec is 1 over cos. So I am saying that 5 over 4 is equal to 1 over cos. And you can inverse so that cos goes up. Do same on the left hand side. If you inverse, cos theta will be 4 over 5. And you know that cos is adjacent over hypotenuse. So you have gotten your hypotenuse which you are looking for. And in fact, you could have actually gotten it from here without punishing yourself to get cos. But the reason why I had to go to this level is that you could have been asked to find cos theta. Am I communicating? Don't worry, we're moving on to other questions you will see. Having said this, we have gotten our hypotenuse to be 5. Therefore, in conclusion, we say sine theta, which is opposite of hypotenuse, opposite is 3, and hypotenuse is 5. So you got the same result as before. Choose whichever of the method you prefer. We are done with this question. We shall pick another of your exam-related question. We shall pick another of your exam-related question. Once network disturbs you, remember to indicate that there is problem with network. That will help me to boost the network, and then we proceed. So we are done with this question. We are done with this question. Let us move on to the next question, still under trigonometry. Let us move on to the next question, still under trigonometry. I'm going to wipe this. I hope you would have snapped it, kind of screenshot. Okay? So you see how fast I'm processing information. This is how your brain is meant to be processing it. There is nothing like, oh, you are GMAT 41, you know this or whatever. You too, you know it. You too, you know it. Either you've been taught or you've studied it in one way or the other. And I've always said this, your exam questions are 1 plus 1. Please, you don't need to be scared of your exam question. The only thing that could cause someone to fail your exam question as it stands is when you're not prepared at all. That's number one. And then number two, when you lack confidence. At least your physics 101 should have told you that. Your physics 101 should have told you that. Maybe you could be complaining time. The only reason why time might choke you is lack of good preparation. When you are still like, hey, are you sure? What are they going to say? I've told you, have nowhere to set questions from. As a matter of fact, your exam questions tomorrow, they are going to be too simple that you might even like, if they know this is what they are going to ask us, why all the stress? Yes, why all the stress? Why not give you area of concentration so that you go and work on it? So be confident, please. Everything we'll do here cover your exam questions. Remember, this is part 3. Part 1 and 2 of this epic super showdown revision is available already, or are available already on this channel. Go through the playlist. I've already created the exam revision playlist for you guys. So we have this second question. That's Q2, question 2. Evaluate sine 2a over 1 plus cos 2a. Evaluate sine 2a over 1 plus cos 2a. Now, how do we evaluate this expression that we have there on the board? This aspect of trigonometry requires your high-level understanding of trigonometric identities, especially the ones that I declared on the board before we started solving questions. If you are not used to all those identities, solving problems like this would be a problem itself for you. Solution. We have to evaluate this. What would it give to us? You know, your exam hall, you'll be given options. In your exam hall, you'll be given what? Options. So you simplify towards the option and see. We are given sine 2a and then 1 plus cos 2a. This is equal to, you have to evaluate or simplify these three functions. We'll come to this sine 2a. Do we have an identity for sine 2a? Yes. Remember, I declared that on the board earlier. Sine 2a is equal to 2 sine a cos a. Good. So you fix that for sine 2a. Then this denominator, is there a way I can work out certain things? I can replace some things that could simplify it further so that possibly any cancellation can be done. Let's see. We have 1 here. How about I write my 1? And then I'll look at this cos 2a and see if there is a way I can break it down. Are you following, right? You have the choice of replacing this 1 with your first Pythagorean identity, square sine theta plus square cos theta, because square sine theta plus square cos theta is equal to 1. Are you following, right? It's equal to 1. But I'm looking at this, that if I do that substitution, and I come here, nothing can cancel. Nothing can cancel. And if I decide to replace 2a with its identity, then you can now start seeing something likely that could cancel. But I'll prefer to, 1 is more simpler than cos 2a. And so I want to rewrite this as cos 2a. What is the identity? Do you remember that cos 2a is equal to square cos a, right? Minus square sine a. Square sine a. That is our cos 2a. That is our cos 2a. That's the identity. Now, I am looking for a way to eliminate one of these square something. Like I said, I could have actually replaced for 1 here using the first Pythagorean identity, square sine theta or square sine a plus square cos a. But I prefer this to eliminate this. 1 is much more simpler than cos 2a, like I said. Let's proceed. This will now be equal to 2 sine a cos a, and then all over 1 plus cos square a, that is square cos a, then minus square sine a. Go back to your Pythagorean identity. Remember, I told you that square sine a is equal to 1 minus square cos a. Because we know that square sine A plus square cos A is equal to 1. So if you make square sine A subject to the formula, it's going to be 1 minus square cos A. Let's do that and see. Open bracket 1 minus, I'm fixing for this square sine A. This is the full column minus, you have it here. Open bracket, the identity of square sine A in terms of square cos A is 1 minus square cos A. And if I do that, open up the bracket and see what is going to happen. This is going to be 1 plus square cos A minus, open bracket, 1 minus square cos A, close bracket. If you open up this bracket, watch. This 1 will become minus because this minus will affect it. Minus 1. This minus will become plus. No basic mathematics. Nothing is there, right? So this expression here is minus 1 plus square cos A. Minus 1 plus square cos A. And minus 1 will go off. They will go off. Minus times minus will give you plus. So this is square cos A plus square cos A, which will give you what? 2 square cos A. This is equal to 2 sine A cos A over 2 square cos A. You see, in exam hall, you're not talking to anybody. Your best friend in examination hall, that best friend terminates. That best friendship ends just about your entering exam hall. At the end of the exam, people can still discuss whether the friendship should continue or not. So you are not talking to anybody. You're not explaining anything to anybody. It's not like now, as I am solving this, I'm trying to ensure you understand one or two things. In the examination hall, if I were to be seated there, I am not going to talk to you. And so before you know, plus minus, in 10 seconds, you are done with solving this. Because you already know how to do your substitution based on the fact that you know your what? Identities. I've listed the key ones you have know in your Math 101. These two we cancel. Sine A cos A. This cos A, we cancel one of the cos A in the denominator. Because this square cos A means cos A times cos A. Are you following, right? We can now conclude, therefore, sine 2A over 1 plus cos 2A is equal to, what we are left with here is sine A over cos A. And sine A over cos A is equal to tan A. Sine A over cos A is equal to what? Tan A. Don't forget that sine over cos is tan. And this is how we have evaluated, we have simplified this trig expression. This is how we have evaluated or simplified this trig identity, this trigger expression. Remember, like I said, those identities I set out before solving questions, you must memorize them to be able to deal with questions given to you under trig identity if you are asked. And of course, one or two of you must be asked questions on trig identity. So if you come to this form where they'll tell you to simplify, evaluate, copy all those necessary identities and fix. We are done with this question. Let me check the network situation before we proceed to the next one. We are moving. Now, this next question I want us to solve, we are going to use it to solve at least two problems. And so you get to know how to use them. After the two problems is sufficient, of course, would have been done with the concept of trigonometry as you expected to prepare for your exam. Please, I hope you've copied this, or you can screenshot it, whatever the case is, so that we move on to the next question. Question 3. Given that sin theta is equal to 3 over 4 and cos theta, this cos alpha rather, I want to use alpha and beta. Because sometimes that symbol is also being used. Sometimes that symbol is also being what? Used. So I'm changing, all these theta and phi to alpha and beta. Are you following, right? To alpha and beta. So take note of that in case. Come in, please. Trying to respond to someone quickly. Okay, so given that sine alpha is equal to, this is 3 over 5, sorry about that, and cos beta is equal to 5 over 13, is equal to 5 over 13. Are we together? Evaluate. Now the main question here is sine alpha plus beta. That's what you asked to evaluate. But I'd like us to evaluate some others. How about I tell you to evaluate cos alpha minus beta? Let's evaluate these two guys. Are you following, right? Let's evaluate these two guys. Solution. Now, from the question given to us, we are asked to evaluate, sine alpha plus beta and cos alpha minus beta. But the examiner gave us sine alpha and gave us cos beta. Now, to start with, you know that to evaluate sine alpha plus beta, the trig identity for this sum of angles is equal to sine alpha cos beta plus you reverse cos alpha sine beta. This is the trig identity. What does it tell you? What does it tell you? It's simply telling us that we need to know the value of sine alpha. Good enough. Sine alpha was given to us in the question, so we don't have problems there. We need to know the value of cos beta. Superb, right? We don't have problem with cos beta. We know the value of cos beta. But look at this, cos alpha. Do you know the value of cos alpha from the question? No, you don't. So we need to go look for it. Look at sine beta. Do you know the value of sine beta from the question? Oh no, we don't. So you have to get their value. So you see, for us to solve this identity, we need the value of cos alpha, and we need the value of sine beta. So you must look for them. Let me check the network situation before I solve that. Okay, let's continue. So we shall now attack by getting the value of cos alpha and sine beta. To get the value of cos alpha, you must go to that angle. You must go to the trig function that bears that angle alpha. Then you do any of the things I did in question 1 of this revision. You can use Pythagoras formula. Pythagoras formula straight. Square of hypotenuse equal to square of opposite plus square of adjacent, and make whatever you're looking for subject to the formula. Or you can decide to use your Pythagorean identity to work it out. Are you following, right? To get cos alpha, cos is adjacent over what? Hypotenuse. Now, from the question, we know sine alpha. This is our opposite because sine is opposite over what? Hypotenuse. So this is opposite from the question. This is adjacent from the question. So if you're telling me to find cos alpha, which is adjacent over hypotenuse, I know my hypotenuse to be 5, right? This hypotenuse is not adjacent, please. Sine is opposite over hypotenuse. So if you're telling me to evaluate cos alpha, which is adjacent over hypotenuse, from the question, the trig function bearing the alpha, I know the hypotenuse already. I know the opposite. My problem is the adjacent. And you can use Pythagoras formula directly, Pythagoras theorem to get it. To evaluate cos alpha, you need the adjacent of this angle. You need the adjacent. Good enough, you know the opposite and the hypotenuse. So how do you get adjacent? Adjacent is simply the square root of the square of hypotenuse minus the square of what? Opposite. That is your adjacent. In fact, I don't have time to waste. I'm going to go straight to start evaluating it. Coming to cos alpha, before we obtain cos alpha, let me speak a little grammar here. For cos alpha, which we know is equal to adjacent over hypotenuse, that is going to be equal to adjacent, we don't know, over hypotenuse is 5. I said that already for this alpha. So let us find our adjacent. But your adjacent, permit me to use A as adjacent. Permit me to use A as adjacent. A. Your adjacent is equal to square root of the square of hypotenuse, and the square of hypotenuse is 5, minus the square of opposite, which is 3. This is going to give you what? 25 minus 9. 25 minus 9 is 16. Square root of 16 is what? 4. What does it tell us? It implies that cos alpha is equal to adjacent 4 over hypotenuse 5. We are done obtaining this cos alpha. Do same for sine beta. For sine beta, you notice that sine, you're going to make use of the trig function that has that angle beta, which is this. So come over to the question. Cos is adjacent over hypotenuse. This is adjacent for this angle, and this is the hypotenuse for this angle. All right, so sine beta, sine is opposite over hypotenuse. Now you come here, we have problem, we don't know the opposite. We only know the adjacent and hypotenuse. Good enough. To get the sine of that angle now, you need to know the opposite of this angle. Use your Pythagoras theorem to calculate the opposite. And how do you get opposite of an angle? So let me write out the formula. This is equal to opposite over hypotenuse of that angle B. Opposite over hypotenuse. And this is equal to the opposite we don't know. Permit me to use O for opposite. Then that is divided by hypotenuse. What is the hypotenuse of this angle? I hope somebody will not think that this is 0. But let me use X as opposite for this angle. Now, what is your hypotenuse for this beta part? The hypotenuse is 13, so this is over 13. Now, we have problem with this opposite. We cannot obtain our opposite, but the opposite X is simply equal to square root of the square of the hypotenuse of this guy. And the hypotenuse is 13, you square it, minus the square of the adjacent. Remember your Pythagoras theorem. Hypotenuse square is equal to opposite square plus adjacent square. So to get the opposite, you subtract the square of the adjacent from the square of the hypotenuse and take the square root. To get the adjacent, you subtract the square of the opposite from the square of the hypotenuse and take the square root. This is just 1 plus 1 math, you know. Your brain can process it just like I am working on it without showing the full Pythagoras formula for you. Look at it. If you simplify this, what will you get? 13 square is 169, right? 169 minus 5 square will give you 25. If I work on 169 minus 25, this is going to give me 4 and then 4 and 1, 144. Square root of 144 will give us 12. Square root 144 will give you 12. You see how I went ahead to do 169 minus 25? I feel like I don't want to crack brain, okay? That's the answer. I don't want to take chances. No try and error. So instead of going to a kind of guess out, 169 minus 25, okay, it's going to be 100 and wasting that time. Show it on paper so as to be sure that you're not making any mistake. Are you following, right? Nobody is telling you that you can't show anything on paper when you are working. If you feel like due to pressure in one way or the other, working it out quickly, from your brain, you might just make a mistake. Write that number you're trying to add, subtract, multiply, or divide on paper, and then you work it out as fast can be. Implication of this is that our sine beta is equal to opposite over hypotenuse of the angle beta. The opposite is what we got, 12. And the hypotenuse already is 13. At this point, you are now set to solve this problem. At this point, you are now set. So the implication is that sine alpha plus beta, I hope I'm not too fast. I'm not fast anyway. Remember, this is revision. It's expected that you have learned 1 or 2 things about this before. Sine alpha plus beta, you come over and substitute, is equal to sine alpha times cos beta. What is our sine alpha? So all of these things given to you, both the one given to you in the question and the ones you evaluated, seek for them and substitute. Sine alpha is 3 over 5. It's going to be 3 over 5 times cos beta. Now cos beta is 5 over 13. 5 over 13. Then plus, following this formula, plus, you come to cos alpha. What is your cos alpha? Search for it. Cos alpha, we got it to be 4 over 5. 4 over 5, then times sine beta. What is our sine beta? Sine beta is 12 over 13. 12 over 13. Simplify this. If you watch this 5 and this 5 will go off, so you'll be left with 3 over 13 here. If you watch this, nothing can divide. Nothing can divide. So this is 3 over 13, and then plus, multiply this out. 4 times 12 is going to give you 48 over 5 times 13 is plus 65. 65. Then work out the LCM of these. Work out the LCM of these. I think 5 times 13 is 65. 5 times 3 is 15. Carry 1. 5 times 1 is 5 plus 1, 6. Good. So look at these two terms. Look at these two terms. What is the LCM of this denominator? What is the LCM of this denominator? You notice that this smaller number 13 can divide 65 without remainder. 65 over 13 will give you 5. So since the smaller number can divide the bigger number without remainder, the LCM is the bigger number 65. So this is equal to LCM 65. 65 divided by 13 is 5 times 3 is 50. Plus 65 over 65, 1 times 48 will give you 48. And this is equal to 15 plus 48 divided by 65. 15 plus 48 is going to give you 63. Is that not so? Yep. It's going to give you 63. So this becomes 63 over 65. Ask yourself, can anything reduce these two terms? Can anything reduce these two terms? I know that 3 can reduce 63. Can 3 reduce 65? No. I know that 5 can reduce 65, but 5 cannot reduce 63. I don't think anything can divide these two terms again. So this becomes your what? Answer. It means that sine alpha plus beta is 63 over 65. It is the same thing you're going to do for this cos alpha minus beta, but you don't need to solve anything again for cos alpha, sine beta or whatever, because you have gotten all the parameters you need to evaluate this cos alpha minus beta. It's just for you to remember the identity. And cos alpha minus beta is equal to cos, that is cos alpha cos beta plus sine alpha sine beta. That's the identity of this guy. Finish up what you have on the board. Finish up what you have on the board. Life Welly Keddy understood, sir. Thanks. You are welcome. I am glad that you understood. You understand what is happening on the board. Let us move on. Let us move on. No time. No time. No time. But like I said, at crucial moments, you see men and women sleeping. The heroes are known to be at alert, on high alert, planning and executing plans for their success. At this point, before you connect to this class, I want to believe that you have taken part 1 and part 2 of this revision already. They've been available for the past 1 week now, right? Good. I decided to conclude with these 2 parts. You know, that's part 3 that is left. I'm wiping so that we can evaluate the other ones. I need the value of this cos alpha, so let me indicate it. I need the value of sine beta, let me indicate it. I'm going to wipe off the other things from the board. Please take note, that's 63 over 65. Assuming it is reducible. If you could reduce that fraction, you have to reduce it. Take note. So the second part of the question, we are evaluating cos alpha minus beta. What is the identity? This is equal to cos alpha cos beta. And then if you have minus here for cos, it's going to change to plus here. And then sine alpha sine beta. That's the identity. Implication. This is equal to cos alpha. What's the value of cos alpha? 4 over 5 times cos beta. What is the value of cos beta? 5 over 13. Then plus sine alpha. What is the value of sine alpha? Sine alpha is 3 over 5. And then you're multiplying by sine beta. Sine beta is 12 over 13. Are you following, right? So we have to simplify the expression we now have. Again, you notice that this and this will go off, and you are left with 3 over 5 times 12 over 13. Nothing can reduce here. So this is going to be 4 over 13. And then plus, I hope I made no mistake in the substitution. Let's check. Cos alpha, I've wiped it. 4 over 5 times cos beta, 5 over 13. That's times cos beta, 5 over 13. Then plus sine alpha, 3 over 5. And then times sine beta, which is 12 over 13. So nothing can reduce here. Therefore, multiply 3 by 12. 3 times 12 is going to give us 36. All over, this times this will give you 65. Once again, the LCM is 65. So this is equal to 65. 65 divided by 13 will give you 5. Multiply the 5 by 4, you get 20 plus 65 over 65 is 1 times 36. You get 36. So you find out that this is going to give us 20 plus 36 is 56, right? Divided by 65. Can anything reduce this term? Can anything reduce this term? I don't think so. I don't think so. 2 can reduce 56. 2 cannot divide 65. So you can do that. 3 cannot divide any one of them. 5 can divide 65, but 5 cannot divide 56. 8 can divide 56, but it cannot divide 65. 7 can divide 56, but 7 cannot divide 65. I don't think anything can divide these two terms. How did I know whether this fraction can still reduce or not? Excellent knowledge of my multiplication, at least from 2 to 9 times table. Since you students resumed, since you migrated from O level to advanced level, that was last year, September, okay, October. GMAT 41, especially in Unizik, I have been singing it. I've been singing it that you don't joke with your multiplication. Take it seriously. Take it seriously, because that is one tool that can help you be able to speed up and analyze your problems in exam hall. You see, now I even heard that in your courses, even Chem 101 or so, you are not allowed to use calculator. You see, second semester is still there. So as you've learned all of these, whatever mistake you made this semester, try to correct it as you prepare for second semester. Conclusion: cos alpha minus beta is equal to 56 over 65. In your multiplication table, I've always maintained, and I say, you only need to learn very well your 2 to 9 times table, and it is sufficient. It is sufficient. We are done with this. We are done with this. I think one more last question under trigonometry, in case you see something like that in your exam. One more last question under trigonometry, in case you see something like that in your exam. Finish up what you have on the board. You can screenshot. Question number 4. If you are being tested, on trigonometry, which, like I said, you must. Yes, some students must be tested on it. You know, this exam, you are taking it batch by batch. So Mr. A may not see a trig problem. Mr. B may see. Now, would you take it for granted? Okay, I don't need to prepare for trig. The question is, are you your examiner? And even if you are your examiner, are you aware that it is not your examiners that control the questions you see? This is automated. Whatever is thrown at you, you answer. So what if you neglect this and you happen to see trigonometry problem in your question tomorrow? You have to learn. And what you're learning is simple, like I said. If sine 2x plus 3 is equal to cos 5 plus 3x, for 0 less than or equal to theta less than or equal to 90, comma, Find the value of x. Find the value of x. Pretty simple problem. This is 1 plus 1. Are you following, right? If you see a problem like this where sine of an angle is made equal to cos of an angle, you can write one of the trig functions in terms of the other one. This is what you want to recall. Now we are given that sine 2x plus 3 is equal to cos 5 plus x. You have to find the value of x. Recall. Sine theta is equal to cos 90 minus theta. Sine theta is equal to cos 90 minus theta. And similarly, speaking of this grammar, just to give you the foundation so you know how to attack this problem. Otherwise, I could have just been solving straight. But if I solve straight, it will make no full sense to you because you don't even have the basis. Similarly, if I tell you to evaluate cos theta for acute angle as shown, this definition means for acute angle that is less than 90 degrees. Cos theta is also equal to sine 90 minus theta. So any one of these two things is used to solve this. Like I said, you must write one of the trig function in terms of the other one. Okay, so let's move on. Assuming I want to solve in terms of sine, this is going to be sine open bracket 2x plus 3 equal to, in place of this cos of this angle, I am going to replace it with sine. Remember that cos theta, cos of an angle, cos theta is equal to sine 90 minus that angle. So cos of this angle is equal to sine of 90 minus that angle. Therefore, this is going to be equal to sine open bracket 90 minus this whole angle. And this whole angle is what? 5 plus 3x. That is our theta in this case. Watch. Cos theta, cos of any angle, is equal to sine 90 minus that angle. Therefore, cos of this angle is sine 90 minus this angle. Now that you have sine here, you have sine here, the argument, the angle in front of a trig function, or any function in front of a major mathematical function, anything in front of it is called the argument. If you have sine GMAT, GMAT is the argument of sine there. If you have exponential GMAT, if you have log GMAT, GMAT is the argument of those special functions mentioned. So you have this trig function sine. You have the same trig function sine here. Since this trig function is the same as this function, automatically their arguments, the angles in front of them must be equal. Therefore, you're going to drop these signs and then equate the what? The angles, the argument in front of them. It is just like this thing we treat under indicial equation. If I tell you that 2 raised to power x is equal to 2 raised to power 5, since the bases are the same, automatically the powers must also be equal. So we're going to apply that principle here. So drop the sign. The implication is that 2x plus 3 is equal to 90. If you open up this bracket, you're going to get 90 minus 5 minus 3x. 90 minus 5 minus what? 3x. Now collect your like terms. You know that this is going to be 2x. I'm wasting my time. Is it children that I am, handling here? If 3x goes there, it becomes 5x. Move this 3 here. So this is 90 minus 5, which is 85, minus 3. 85 minus 3 is going to give you what? 82. Telling us that 5x is equal to 82. And then your x is equal to 82 over 5. This is the value, or depending on what the option is, you go for it. If the option is in this format, fine. If it is converted to mixed fraction, fine. If it is given in decimal, fine. 82 over 5. 5 can go into 8 one time. Remainder what? 3. Attach the 3 to this 2, you get 32. 5 can go into 32 6 times. Remainder what? 2. That is the last remainder. So this is going to be 16 whole number 2, or converting to decimal, you write the whole number 16, fix your point, come to the 2/5, attach 0 to the back of this 2, you get 20. Divide the 20 by 5, you get 4. So this is 16.4 degrees, or just 16.4. Are you following right? 16.4. So you want to have this in mind, please. And I want to say this quickly. Please remember the conversion of your angle. Conversion of angle between the following units. Converting angle from degree. Angle from degree to radian. From degree to radian. This is a key area also. You can be asked some funny, extremely simple question. On this channel, in the GMAETS 41's short section, YouTube short section, I have a question. It's actually UNIZIC past question. Yes, UNIZIC past question, I think 2-3 years ago or so, where you are given an angle in degree, there about maybe 60 degrees, and you are asked to convert it to radian. If you are given angle in degree and you're asked to convert to radian, multiply that degree angle by pi over 180. That's the conversion factor. To change from degree to radian, that degree value given to multiply by what? Pi over 180. Simplify, and then you get the angle in the unit of radian. And if you are given in the unit of radian to change back to degree, do the opposite multiplication. Multiply the radian value given to you by 180 over pi. I think I also covered that in your Physics 101 anyway, under circular motion. So it's nothing. We are done with trig, and that's good. We are done with trig. So where is your physical class being held? Live KD, right? Okay. My physical tutorial holds on campus in UNIZIC if you're a UNIZIC student, right? So you can always contact GMAETS 41 on this contact to know the venue, but it's within engineering faculty, all right? Very close to Jupiter Hall, very close to Jupiter Hall, close to Science Village, along New Road, okay? So that is it. But like I say, you can always contact GMAETS 41 to get further information about our classes. And you know one good thing, everything you're going to do in your second semester, Math 102, Physics 102, Chem 102, Organic Chemistry, Math 102 is calculus, but of course, that Math 102 is far, far, far simpler. I've not seen any math that is as simple as that compared to Math 101. No go area. Math 101 is by far tougher than Math 102. Some of you are being deceived already to start being scared of calculus and that Math 101. Take note, it's 1 plus 1, far simpler than Math 101, please. Take note of that. Math 102 is simpler, but you need GMAETS 41 to prove it for you. Your Phys 102 concept of electricity, right, and magnetism, as well as light. Your Chem 102 organic chemistry. Your Phys 108 practical, electricity and light practical. Your Chem 108 organic chemistry, qualitative analysis. All of them are completely available on this channel, even before you got your admission, right? I don't know, but I think individual has decisions to make. But I don't think any UNIZIC student, if you're a UNIZIC student, knowing about GMAETS 41 and you contemplate it, there is no comparison. With all humility, there is no comparison there. Take note, in case of your second semester, I come early time, do my adverts, and I just disappear. I feel that getting to see me online, and as I talk about my tutorial, for those that need physical tutorial, is sufficient for you to seek for me. Yes, we should understand this. As students, you should seek for where to learn. You don't wait people to come and start talking, where you get confused. Observe. Where will you get the best? Like I said, your second semester is here to start. At the end of your exam, you take a little break. Within that 1 month, you can cover 1-2 courses before you return. Core interfaculty courses, only on the GMAETS 41's platform. Registration for second semester is open anyway, because we don't wait. And then somebody will say, but we've not finished first semester. You're talking second semester. That is it. No time. I'm wiping this place. Let's review the other two topics possibly that are left. I'm done with trigonometry. I'd actually touched work on AP and GP, but I'd like us to solve this problem actually from your workbook. All right, on sum to infinity. That is AP and GP. On the playlist, or rather in the playlists of Math 101, where I'd already arranged all these things this semester for you guys. You have, I think, 2-3 videos, where I dealt with the concept of AP, GP in terms of their formulas you should know and how to solve some questions. Let us deal with this particular problem. Given the series, this is question 1 here. Given the series 2 plus 3 over 2 plus 9 over 8 plus 27 over 32 plus continuously in that way. Given this series, evaluate this. That means you have to evaluate sum to infinity of this GP. Use sum to infinity for a GP is simple. AP and GP are also simple context, right, in your exam, and of course as a topic you're dealing with. It's all about formula. So once you have the formula, your problem is solved. What is the formula for solving sum to infinity of a geometric progression? It is the first term divided by 1 minus the common ratio. That is the formula. The first term divided by what? 1 minus the common ratio. So what do you do here? Your first term from the question is the very first number there, which is 2. So our A is 2. Your common ratio is for you to take a divisional relationship, a ratio between any two consecutive numbers. You can do 3 over 2 divided by 2, or you do 9 over 8 divided by 3 over 2, or you can solve out 27 over 32 divided by 9 over 8. Which one do you think will be faster for you to get your result of the common ratio? Do that. From the question, A is equal to 2, like I said, our common ratio is equal to, if I were to be in examination hall, I'll be doing 3 over 2, then divided by 2. This second term over the first term. And of course, this mathematics, if you work it out, is going to be 3 over 2 times 1 over 2, which will give you 3 over 4. 3 over 4. Mathematically, this 2 standing alone is over 1. So what happens is simple. The denominator of the numerator and the denominator of the denominator, they will switch and meet the respective numerators of those guys. Big grammar, isn't it? This is what I mean. These two denominator will come to this numerator under, and this 1 will go to the numerator on top. That is it. So the denominator of the numerator and denominator will switch. They will switch, and when they are switching, they are meeting the numerator of, the numerators you have there. Okay, so that is that. I have explained that. So what do we do here? All we just have to do is to substitute into the sum to infinity formula. Our A is equal to 2, and then divided by 1 minus the common ratio is 3 over 4. You can simplify this. LCM of the denominator is going to give you 4 times 1, which is 4, minus 3, which is 1, everything 4. So this is 2 divided by 1 over 4. This 2 is the numerator standing alone. That 2 is 2 over 1. I hope you're getting me right. So this is actually 2 over 1 in the numerator, all over 1 over 4. And like I said, their denominators will switch position. So simply this 4 will climb to meet this 2. The invisible over 1 of the 2 will climb down, will move down to meet this one. So of course, you're going to get 2 times 4 over 1 times 1, which is going to give you 8. This is the sum to infinity of this guy. This is the sum to infinity of this guy. We are done with that. A very simple problem. You need to know the formulas for calculating the nth term of a GP. You need to know the formula for calculating the sum of a GP. Are you following? Those things are just 1 plus 1. Nth term of a GP, which I can write as Tn, is equal to the first term times the common ratio raised to the power n minus 1. So that's the formula. If you're talking about the sum of the first nth term of a geometric progression, sum of the first nth term of a GP, okay, the formula is the first term, open bracket, 1 minus r raised to the power n, then all over r minus 1. All over r raised to the power n minus 1, right? R minus 1. All over r minus 1. Now, this is a case where 1 is greater than the common ratio. When 1 is bigger than the common ratio, you use this formula. If the common ratio is bigger than 1, that is, if r is bigger than 1, the formula will take this format. Sn, what did I write here? I'm sorry about that, please. This sum of the first n term of a GP, I'm assuming that 1 is bigger than the common ratio. So the denominator should be 1 minus r. 1 minus r. Okay, yeah. Now, if your common ratio is now greater than 1, if your common ratio is greater than 1, then the sum of the first term would take this format. The first term, then bracket r raised to the power n minus 1. Remember, r raised to the power n, then minus 1. You have to evaluate r raised to the power n first. Anything you get, you subtract 1 from it. Take note. Then divide by r minus 1. So this is the formula in a case where it happens that the common ratio is bigger than what? 1. How to apply this formula is 1 plus 1. Okay, so I'm not going to waste time there. I'm not solving any question there. Make use of the playlist. Okay, you see 1 or 2 things, I guess, on AP, and the knowledge there will guide you to how to handle. I've solved the one that my mind asked me to solve for you guys. Sum to infinity. We are done with AP and GP. Remember, I'm focusing on the topic I did not touch in part 1 and 2 of the revision. After part 2 of your Math 101 exam focus revision, I actually encourage the student to go through the playlist. Are you following right? In fact, in the home section of this channel, if you log into this channel, okay, the home of GMAETS 41's channel, scroll. As you scroll through, you are going to see the arrangement of your courses for this semester very well. Check the section containing the playlist containing AP and GP. So I actually encourage students to do so. I encourage them to take those lessons, but I decided to solve 1 or 2 things for you in those parts that I did not touch. Let us look at problems on combination. Combination. I already covered permutation, all right, and binomial expansion, your key exam questions in that part. I think part 2, if I'm not mistaken. So I'm moving on. AP and GP is not a problem. You already even learned them from your O-level work. So let us move on to combination, which is the last part I want to touch. Like I said, as serious students, you should have taken your part 1 and 2 already. So this is just the final address. Okay? Combination. I'm not going to write on combination. I'm just writing combination alone. Because like I said, I've touched permutation. Not touched. I solved permutation problem very well. Or should I write permutation and combination? Let me solve if possible. Let me just write it because that's the topic. Permutation and combination. But I'm solving combination problem. I'm solving combination problem. Let's take the first combination problem here. Okay, question 1. Given that n and then n minus 2 equals n and then n minus 3. Evaluate n combination. Evaluate n combination 8. Solution. Is this your first time of seeing this symbol used for combination? Take note, n combination r is still the same as writing n and then r with this long square bracket like this. Okay? Or it is still the same as expressing it as combination bracket n comma r. So take note of these symbols. Your examiner can use any one of them for you. I decided to use this symbol because it could be strange to some of you. What they ask you to evaluate there is n combination n minus 2, and that is equal to n combination n minus 3. That's the meaning. And then you're asked to find n combination 8. This n combination 8 you were asked to find, they could still have written it like this, n8. It means n combination 8. Take note. Let me check the network situation, please. All right. We are moving on. How much is the tutorial? Please, you can start off, okay? These are not things I talk about now. This online class, live class, and if it is online class you're joining, my general online class, just make use of the channel membership, okay? For physical class, please contact GMAETS41 directly on WhatsApp or by call, and you will get the response that you need. Now, when you see something like this, as your examiners usually love asking, they love this thing. They love this thing. Huh? The principle you use in solving it is complementary combination. Complementary combination. Don't go punishing yourself using n combination. Don't do that. If I give you n combination 5 to be equal to n combination 8, it simply means that n is equal to 5 plus 8. To get your n, it is 5 plus 8. Are you following, right? Yeah. So take note of that. This is n combination 5. Here, it is still that same n combination whatever. How do you get this your n? Add these two guys. Add the items you are selecting. Remember that combination is a way of selecting a given number of objects, say r object out of n total objects. So if I have maybe 5 people and I say that I need to select, okay, let's say I have 5 boys and I have, let's say, 7 girls. And I say I need to set up a committee from these boys and girls. And the number of committees, the number of people that should be in that committee should be, let's say, 3. Should be what? 3. And that there must be a girl, there must be a boy. That is, a girl must be in the committee, boys must also be in the committee. So you come to the boy, you select. Assuming you select 1 boy. So out of boys, you're selecting 1. And maybe you select 2 girls. Out of the 7 boys, you're selecting 2. So combination is simply selection, while permutation is arrangement. Are you following, right? So if you know the number you are selecting out of n, you also know another number you are meant to select out of that same n. To know the value of that n, add up the 2 numbers. We call that complementary combination. Please let us attack this question straight on. Let us attack. No time to go deep into explaining anything. Now I'm going to rewrite what was given to us to be n combination n minus 2 is said to be equal to n combination n minus 3, and then you are asked to find n combination no. So from complementary combination, but n is equal to n minus 2, then plus n minus 3. So that our n is going to be equal to, you come over to this, open up the bracket. If you open up this bracket, you still get n minus 2. Open this one, you get n minus 3. N plus n will give us 2n. See, I tried to like come up with just a random question. This is a random question. Sorry, I didn't have the source per se bringing out this particular question. I didn't have the source. And so it's seeming that something might happen. But it doesn't matter. If I don't get what I'm expecting to get, I would increase the numbers. Don't worry. I know the question I'm talking about. But sometimes can do some things to prepare students for certain, challenges. The question usually comes this way. It comes this way. Okay, let us see. If I work on this, minus 2 minus 3 will give us minus 5. It gives us minus 5. You work on this. You're meant to get minus 5. And then collect your like terms. 5 comes here, becomes positive. N goes there. 2n minus n will give you n. So n is 5. This cannot be. This cannot be. So what I'm going to do, n can be 5, take note. But what I'm saying it cannot be is what I wrote here that we should find. You cannot do n combination 8 where n is 5. You can't do that, right? Because usually the total number of objects out of which you are selecting something from, the total number of objects should be greater than what you are selecting. So I'm sorry, I'm going to, like I said, change the number. Let us evaluate n combination 2. Let us evaluate n combination 2. That is what I want us to evaluate. Good. I've adjusted the question. So with this, we are good to go. The value of n is 5. The value of n is 5. Your examiner can simply ask you, find n from here. See this problem, just find n. Like I said, your questions are 1 plus 1. Nobody is interested in intimidating you, giving you questions that will choke you. They're 1 plus 1. So you see this thing, just like I taught you. In your exam tomorrow, you could just see a question and then they're asking you to find n. All right, now that you have gotten the value of n combination 2 will now be equal to 5 combination 2, and that is equal to, what is the formula for combination? Just as a reminder, n combination r is equal to n factorial divided by n minus r factorial multiplied by r factorial. This is combination formula. Are you following right? So we're going to apply that formula here. We're going to apply it. So this is going to be our n is 5, our r is 2. So it's going to be 5 factorial rather, all over 5 minus 2, n minus r. Are you following right? 5 minus 2 factorial. 5 minus 2 will give you 3 factorial, and then r factorial, where r is 2 here. So you have 2 factorial. You can simplify this. 5 factorial is 5 times 4 times 3. I am going to stop at 3 factorial, and I will tell you the reason. In the denominator, I have 3 factorial, so I want the 3 factorials to cancel out. You don't need to do this thing, punishing yourself 5 times 4 times 3 times 2 times 1. In fact, if I'm even to expand it to the end, I don't even like fixing that one, because a number times 1 is that same number. I prefer stopping at 2. Even though factorial definition means multiply something by itself, right? Multiply something by a number which is 1 less than it. Continue doing it until you get to 1. Like 5 factorial is meant to be 5 times 1 times 5 times 4 times 3 times 2 times 1. But even if I am doing it that 1, I don't like showing, I don't like doing times 1. It's a waste of time. And again, whenever you're expanding this factorial concept, if you have a denominator and that denominator also has factorial, let the denominator guide the extent to which you are expanding the numerator. So here is going to be over 3 factorial times 2 factorial. And that 2 factorial is 2 times 1, or simply 2. Are you getting me right? I don't like that one I wrote there anyway. The 3 factorial will cancel this one. You are left with 5 times 4 over 2. This 2 here, 1, 2 into 4 will give you 2. And then 5 times 2 will give us that n combination 2, which is equal to 5 combination 2 is equal to 10. That is the solution to this question. Now, you see this question, we actually attacked 2 problems in one. We used this question to obtain the value of n, and we also used it to evaluate the n combination something. We use D to evaluate n combination 2 in this case. Our last question as we conclude this revision class. I'd like us to solve a problem on combination whereby you have a group of a particular gender, group of another gender, and you're asked to form possibly a committee, select something. Or you have, colors of balls mixed together, and you're asked to select, draw out some balls from, the number of balls you have. So let us solve this question. This question is directly from your workbook. It's directly from your Unit Math 101 workbook. And of course, you know that the solution to that workbook, right? It's completely on this channel solved. You can go through the workbook playlist on this channel, workbook playlist, and still take some revision, all right? Because some of your exam questions will also come from the workbook directly. They can lift straight on from there. Part 1, Part 2 revision, together with the Part 3 conclusive revision here, and your workbook. If you take your time to solve all the questions that are there, you enter the exam hall and smile. If they give you 15 minutes to answer, let us say 20 questions or 25 questions, in 8-7 minutes, you are done. In 8-7 minutes, you are done. Please, dear friends, you see, there is something, I want to say it, right? It's not insulting. Take note of that, please. It's a way to try to awaken you friends. Like I said, look at what I'm doing now. This is late midnight. I think by the time here, 1:25 a.m. midnight. You could still see some persons sleeping, Some of them would have prepared very well. They would have studied, maybe covered everything they need to cover, because on this channel, they prepare for this exam, we're already available. There are still many others who do not even know what they are going into the examination hall tomorrow. Is it tomorrow, later in the day for? They don't know. Yes, but they are busy sleeping now. They are busy sleeping. They are preparing to let my people go if they enter examination hall later. Please, you don't want to be like that. We shouldn't be lazy. We shouldn't be lazy. That's the word I wanted to use. Please, I don't encourage that. I don't. Even the workbook solution, most times if I'm solving, then I will tell students, get to understand how this thing is being done. Because on the D-Day, you will be inside the exam hall, GMAT 41, and or whomever you have placed your trust would be sleeping and taking 139 bottles and praying for you, because people like prayers than working. Prayer is good. I encourage it a lot. I'm very prayerful. But you must work, because like the Bible said, God's clear word, faith without work is dead. Praying without ensuring that you study and you do things when you're supposed to do it, that prayer is a waste of time. So you are disturbing God. Please, let's conclude. Let's conclude. Question number 2 under combination. From a bag, pay attention as I dictate the question, please. This is the last question. This is the last question. From a bag containing 7 black balls and 5 white balls. From a bag containing 7 black balls and 5 white balls. How many sets of 5 balls? How many sets of 5 balls, of which 3 are black and 2 are white, can be drawn? I repeat that question. From a bag containing 7 black balls and 5 white balls. So inside the bag, we have 7 black, 5 white balls. How many sets of 5 balls, of which 3 of them are black and 2 are white, can be drawn? That's the question. So let us attack and see how we solve the problem. In the bag, the total number of balls are 12, but looking at the total number of balls here, reason. In the drawing, go to pick the balls, you are told to pick 3 black and 2 white to make up the 5 balls you have to draw. So we're going to treat them independently. Number of black balls. Black balls, 7. Number of white balls. White balls. The number of white balls, how many are there? We have 5 of them. 5. Now, the selection you are meant to do. Take note that this question is still similar to that type of question which I mentioned earlier. You could have some number of girls, some number of boys, and you are asked to form a committee. You are told the number that is going to be in that committee. And you are told to select from the girls and select from the boys to make up that committee. So this particular problem we are dealing with, right, explains that type of question as well too, because I might not solve any question on such type of problem. Just remember, you have 2 independent things, supposedly. Pick some here to make up the number you are looking for. So, in a question, the number of balls you have to draw out, which means pick out. Draw, I am writing like, I don't know. Draw out, just pick out 3 blacks and 2 whites. That's what you are meant to do. Okay, so the question asks, how many sets of 5 balls of which 3 are black and 2 are what? White. So set of 5 balls, set of 5 balls, in brackets, 3 blacks and 2 whites. This is just like probability problem, probability, set, permutation and combination, they are interrelated. So here this is going to be equal to, out of 7 black balls, you are picking 3. Out of 7 total black balls, you are selecting 3. That is written as 7 combination 3. And out of 5 white balls, you are selecting 2. And as used there is multiplication, so this is going to be times. If it is or, you fix plus. Or is plus. So this is going to be times, out of the 5 white balls, you are selecting 2. This is the solution to that problem. So your examiner can leave the option like this. The choice is theirs. Are you following right? Remember that instead of times, I can fix a dot. Dot between. Dot is still interpreted to mean multiplication. But I want us to solve this problem. Let's get a final result. This is 7 factorial divided by 7 minus 3 factorial times 3 factorial. 7 minus 3 will give us 4 factorial, then multiply by 3 factorial. This is multiply 7 combination 5 combination 2, which is 5 factorial, over 5 minus 2, which will give you 3 factorial times 2 factorial. We can simplify this term. This is equal to 7 factorial expanded. Let me get down. This is equal to 7 factorial is 7 times 5. I mean 7 times 6 rather. 7 times 6 times 5, then times, I'll stop at 4 factorial. Divided by 4 factorial times 3 times 2. 3 factorial is 3 times 2 times 1. I don't like that one. It's a waste of time in the examination hall. Come over to this. 5 times 4 times, I'll stop at 3 factorial because of the denominator. Divided by 2 factorial is 2 times 1. I don't like that one, so I'm going to just write 2. So this is 3 factorial times 2. 3 factorial times 2. 2 factorial is 2 times 1. 3 factorial will go off. 2 here, 1. 2 here, 2. 4 factorial will go off. 3 times 2 is 6. So this 3 times 2 will go off with 6 in the numerator. 7 times 5 is 35. So this is going to be equal to 35 times, come over to this, 5 times 2 is 10. Therefore, your final result is equal to 350. It's going to be what? 350. So if you are to do the draw, you are drawing and you're going to get 350 sets of balls. Are you following? Can be drawn. 350 sets of balls can be what? Drawn. And that is the solution to this problem. That is the solution to this problem. That is the solution to this problem. We are done with it. I'll wipe this. And we are done with this revision per se. But there is one more question I want to solve. I just want to open your eyes to it, because normally, many times, students think that that question is not part of your outline. Yes, many times students think that that question is not part of your course outline. Normally, it is really not meant to be part of your course outline. Okay, but it is part of your course outline indirectly, and I will tell you why. I will tell you why. Under quadratic equation, when you are dealing with the discriminant b squared minus 4ac, when you are dealing with that guy b squared minus 4ac, under what condition in quadratic equation, that part of quadratic equation formula that is square root b squared minus 4ac, that b squared minus 4ac is called discriminant. Don't be shocked that tomorrow in your exam, your examiner simply asks you, the discriminant of a quadratic equation is given as, the discriminant of a quadratic equation is given as simple as that. It's given as b squared minus 4ac. Come on. Dear friends, I've told you your exam is 1 plus 1. You can blast it. You can do it. I believe in you. Go in there and get the GMAETS 41. Your A splashes. Right? You can do it. Please. You see all of the things you've done this semester, the stress you went through, and what have you? It's far, far greater than the exam questions you will see. Sometimes the exam question get me so pissed off. I'll be like, come on, so if people know you're going to ask this, why all this stress? But of course, they don't want you to fail. That is the truth. They want you to have excellent results from your 100 level, because this level is the level you have the opportunity to grab that first class, then start building your GP very well, and eventually you graduate with first class. Now, under quadratic equation, we have types of roots of a quadratic equation. When that discriminant b squared minus 4ac, imagine I give you a particular quadratic equation, and then you pick out ABC, you fix it into the discriminant formula b squared minus 4ac. Assuming you simplify that and you get 0. If I give you, let's say, x squared plus 2x plus 3, right? Okay, let's say plus 3x plus 2. I can ask you, what type of root will this quadratic equation give to you? What type of root will it produce? To answer that question, this is what you use, b squared minus 4ac. Are you following? What type? And there are 3 types of roots. We have real and equal roots. Real and equal roots. When do you expect to get this type of root if you solve a quadratic equation? You get it when b squared, the discriminant, we use d to represent it. You get real and equal roots if discriminant is equal to 0. Real and equal roots. Then if you have real and unequal root, under what condition do you get real and unequal roots? Real and unequal. So that means if you solve the quadratic equation, you will get real numbers. But the real numbers will not be equal. Under this condition, the discriminant is greater than 0. The discriminant is greater than 0. And then the final one is when you get imaginary root. Imaginary root. Imaginary root. Imaginary root. When do you get imaginary root? That is when your discriminant is less than 0. That is to say the discriminant is negative, i.e., that is negative. If discriminant, this d gives you a negative value, when you substitute into this b squared minus 4ac, pick your if a here is 1 for this guy, b is 3, c is 2. Fix it here and simplify this small equation or whatever you call it. If this guy gives you 0, then the root you're going to get will be real and equal root. If it gives you something greater than 0, you will get real and unequal root. If it gives you something less than 0, you will get imaginary root. That is, not real numbers. Are you following right? Now, based on this, you notice that inequality has come in. You know why I took my time to talk about this is, one may be wondering, inequality, is it part of your Math 101 course outline? Partly yes, partly no. Yes, because quadratic equation brought it in under this discriminant types of roots of a quadratic equation. For that reason, let's just solve this question. Although the question is not quadratic equation, it is purely inequality problem. And this is the question. This is the question. It's in your manual. Take notes. It's in your manual. Solve 3 bracket x minus 1, 3 bracket x minus 1. All the solutions to your manual question, like I said, they are available on this channel. Go to the playlist or the home page. Scroll gradually. You would see workbook section. Workbook section. Math 101, Chem 101, Phys 101, and even your next semester, second semester workbook solutions. They are available there. So 2 bracket x minus 3. You are asked to solve this equation. We'll solve this one, then solve the last one. Okay, and I think with that I am done. My mind is now free to say yes, I have covered the things I should cover for these friends. 3 bracket x minus 1 less than or equal to 2 bracket x minus 3. So you open up this bracket, 3x minus 3 less than or equal to 2x minus 6. That is just simple math. It's basic math actually. And then you collect like terms. 3x, 2x will cross, it will become minus 2x. 3x minus 2x will give you x. Then minus 3 will cross. If minus 3 crosses, you have minus 6. Minus 3 will become plus here. So minus 6 plus 3 will give you minus 3. This is the value of x. Very simple. Take note that you did not multiply anything or divide anything here by a negative number. Take note you did not. I say this because if you multiply or divide inequality by negative number, the sign will change. For example, assuming that we had minus x to be less than or equal to 3, for example. You are looking for x, so it's not allowed to bear that minus. Therefore, you have to multiply both sides by minus, or if you say divide both sides by minus 1, the choice is yours to take the negative to this 3. When you are doing that, the sign will change. Multiply here by minus 1 or divide it by minus 1 to remove the minus. Then as the minus is coming to the right side, this sign will change. So you have something like this. Take notes. Let us now look at the next inequality problem, like I said. This is question 1 here, then question 2. In this question 2, we have 3x minus 4 all over 2 greater than or equal to x plus 1 over 4. Whenever you have an inequality or an equation, please take note exactly the way you solve mathematical equation problem is what you do whenever you are solving inequality. The only difference between solving inequality and normal equation is this thing I told you about. If it happens that at a point you are using negative to multiply or divide, the sign will change. That's just the only difference. In here, we are going to, since what you are looking for is x, and the x is in fraction form, and you notice that on the left, you have a single fraction, only this fraction. On the right, you also have only single fraction. Mathematically, the principle of simple equation you are expected to apply is to cross multiply. So this is going to give us 3x minus 4 all over 2 greater than or equal to x plus 1 over 4. Cross multiply. So this 2 is multiplying everything in the numerator here, and 4 is multiplying everything in the numerator here. Let's do that. 4 times 3x will give us 12x. 4 times minus 4 is minus 16. Greater than or equal to 2 times x is 2x. 2 times 1 will give you plus 2. Then you see this has become something like this. Collect your like terms. I'm moving this 2x here. 12x minus 2x will give us 10x. Then greater than or equal to, you have 2 here. If 16 moves, you're going to get 18. So get the value of x, divide both sides by what? By 10. So x is greater than or equal to 18 over 10. This can be reduced. This can be reduced. 2 can go in here, isn't it? If 2 goes in this, you're going to get 9 over what? 5. So this is the value of x supposedly. I hope I didn't make any mistake here. Or did I? Seems like. So that's the question. But I guess the question I actually wrote out was wrong. It was wrong. We have minus here actually, minus 1. We have minus 1 in that question. But it doesn't matter. We have minus 1. But based on this one I've solved, this is the result. This is the result. You can put this in mixed fraction. 5 can go into 9 one time, remainder 4. So 4 over 5. Or if you like to put it in decimal, depending on the option, this is going to be 1.8 or 1.8. Okay? So you take note of that. I'm still going to solve this one, but I'll be using minus exactly what we have there. I'll be using minus exactly what we have there. So let me wipe this. Let me wipe this. I'm going to call that question number 3. I'm going to call that question number 3. Solve the inequality. So we have 3x minus 4 over 2, then greater than or equal to x plus 1 over 4. Then you have minus 1 on its own there. That's actually the main question. That's actually the main question. Now you notice that this one I solved here, where I mistakenly omitted this one. I told you that what to do first is to cross multiply because you had a single fraction here and a single fraction here. Are you following? In this case, you can't cross multiply directly. You can't. You can't. And the reason is very simple. Although you have a single fraction here, on the right hand side, you don't have a single fraction. This is a fraction. This one standing alone is also a fraction on its own, although it's a whole number, but it's separate from this guy. This is 1 over 1. Are you following, right? It's 1 over 1. Therefore, all you have to do here is to clear your fraction. That's the best approach. Clear your fraction using the LCM. What is the LCM of this inequality? If you look at the denominator, this is 2, 4, and invisible 1 here. Whenever I have over 1, 1 is not a problem. Just keep it aside. It does not contribute to your LCM. So we are left with 2 and 4. The smaller number 2 can divide 4. Therefore, the LCM will be the bigger number. So use that LCM 4 to multiply each of the numerators. When you use 4 to multiply this part, notice what the denominator will do. Use the LCM 4 to multiply this numerator. Notice what the denominator will do. Then use it to multiply this whole number standing alone there. So 4 times this, if this LCM 4 multiplies this part, these 2 in the denominator will reduce it. So what you're going to have here will be 2 brackets 2x minus 4. Remember, the LCM is 4. Use the 4 to multiply this. So you have 4 here. These 2 will reduce this 4. You get 2 here. That's what I just did. Greater than or equal to, do same here. The LCM 4 comes on top. This 4 will divide it. It will go up. So you are left with x plus 1. And then the LCM times minus 4, minus 1 will give us what? Minus 4. Open up this bracket, you have you have 4x. Open up the bracket, you have 4x minus 8 greater than or equal to, this is x plus 1 minus 4, which will give you x minus 3. You have to collect your like terms. This x will come over here. If it comes, it becomes what? 3x, and then minus 8 will cross. Right? Let's take a look at this very well. If minus 8 crosses, it's going to meet up this, and you would get 5. I think, let me see, that I didn't make a mistake again in the question. 3x minus 4. I just keep making this mistake. 3x minus 4. Gosh. Annoying, isn't it? Please, sorry, that's the human part of the GMAETS 41. This is 3. So this is meant to be 3. And then if you open up this bracket, this is meant to be 6. Good. So that if this x crosses, this will become 6x minus x, which is 5x. Then minus 8 will move, greater than or equal to minus 3 plus 8 will give you 5. Divide both sides by 5, and then you would get x to be greater than or equal to 1. You get x to be greater than or equal to 1. And that is the solution of that guy in your workbook. I think in that workbook, it's actually question number 7 of the module where this thing appeared. I think module 3, if I'm not mistaken. Is it module 3 or module 2 or 3? I think it should be module 3. That's where you have it. That's where you have it. So that is it. And I think this is sufficient as per the revision part 3. Are you following right? Like I said, every other topic in your Math 101 has been revised. Full potential, right? Your exam questions will come from there directly. That's the truth. That's the truth. Even if they decide to do any otherwise or whatever, they can't change the structure of the exam question, which means your ability to cover part 1, part 2 revision, together with this part 3, you have covered everything. If you don't want to go through your workbook, no problem. If you decide to still go through your workbook, fine. But of course, by the time you're able to revise part 1, part 2, part 3, and you pick your workbook, you see that everything there is play, 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 and play. Are you following right? So that is it. I wish all of you the very best. Of course, you always know that there's nothing else the GMAT 41 wishes you, dear friends, other than going in there, like I've always said, hold your examiners to a standstill and tell them, you can't score me, you can't dribble me, because I have operated with the GMAT 41. I wish all of you the very best, and I'll be seeing you finally in your Chem 101 revision. Are you following right? We are done with Physics 101. I am pretty sure 100% that you were not disappointed if you stuck to my instructions, if you followed it very well. The same with your maths. But still that your maths will be very, very simple, far simpler than your physics even. That's the truth. Far simpler. But make sure you do the needful. Cover all the revisions. Cover all of them. You talk about time or whatever, it doesn't matter. Cover it. It's a video lesson from the comfort of your home. Like I say, part 1 and 2 should have been covered before today. Yeah, they should have been covered. Go in there, please, and get the GMAT 41. Those A splashes. Success in your examination. But like I said, to all of you there who didn't have the opportunity of joining the GMAT 41's full tutorial this semester, second semester you have the opportunity. Are you following right? Please don't contemplate. Don't contemplate. Start now and start making contact. Contact GMAT 41 for your registration or to get information about the registration for second semester. No time. I kick off immediately. You guys are done with your first semester exams. I just give 1 week and I kick off second semester work online, pending when school resumes after like the 1 month break they will give to you guys. Share this link to your friends, right? I've told you to access part 1 and part 2 of the revision. Are you following right? Go to the playlist on this channel. Just check in the home page. You check, you see playlist, tap it. Then just scroll a little. I think the first section there is the revision section. Of course, you can join the platinum level or the diamond level to support this channel and get full access to everything. All right, yeah, when I say everything, don't joke. Don't joke. Your exam questions and how you solve them. Yeah, how fast you should attack them. How fast you should attack them. And then, of course, for your workbook, some of you already don't have the workbook again, and you did not even take the time to copy out the question. Whatever the case is, GMAT 41 got your back. So you go to the home page, then you scroll the home page of this channel, scroll gradually, you would see the workbook section. Okay, click on it. If it opens, scroll down, then you would see all the maths, because I guess we have Chem 101, the order of arrangement, Chem 101, workbook solution first, after that Physics 101, and then Math 101 follows. Okay, there you also get the solutions to all of these things. The concept of your set notation, they're already available in the revision section. You know, the concept of your type of numbers, where you can be asked if you are given n union z, we give you what? The answer is still z. The answer is still what? Z. Natural number union integer will still give you integer. Are you following? If I give you something like rational number intersection irrational number, right? Rational number intersection irrational number, this is going to give you an empty set. It's going to give you an empty set. Use this symbol for empty set, or use this one for empty set, you know, because there is no way rational and irrational numbers can intersect. It's not done. But what if I give you rational number, okay, union irrational number, and then maybe this union irrational number will give you real number on its own. Are you getting me right? To give you real number. But imagine now that I give you a rational number union irrational number in bracket, and then I decide to intersect this with, let us say that I intersect this with natural number. What is going to be your answer? When you take the union of these two guys, like I said, you will get real number. Real number intersection natural number will give you natural number. Anytime the larger type of number intersects with smaller type of number, the answer is that smaller type. I explained all of these things under the video lesson covering, you know, these types of numbers. They are there under the revision section. Please make use of the revision playlist, like I said. Are you getting me? If a larger number, like real number is the largest number separate from complex number. Every other number came from real number apart from complex number. So if you have real number, which is a larger number, in this case, intersection integer, the result will be integer. Sorry, intersection natural number rather. The result will be natural number. The same, if it is intersection integer, the result will be integer, because all those other numbers are smaller than real numbers. But now if you are taking the union, assuming I have this union this, and then union natural number, the answer will be real number. So remember this tree, please. Remember this tree. Where do I wipe? Remember this tree. How they are being, you know, how the numbers are being given birth to. I'm focusing on real number. I wouldn't say anything about I wouldn't say anything about complex number. So real number gave birth to two numbers. One of them is rational, and the other one is irrational. So this union this will give you this. These are numbers that can be written in ratio format as rational number, in fraction form, whole numbers, natural numbers, integers. They are also under these rational numbers. Irrational is just one type of number on its own. Pi is irrational. The natural logarithm e, that symbol e, is then calculator that is equal to 2.71 something, is irrational number. Salts are irrational numbers. Okay, let's move on. This rational number now give birth to integers, right? And then integers give birth to, we can say, whole numbers, and whole number give birth to, we can say, natural numbers. This is how your numbers are arranged in terms of the one that comes as a subset of the other one. So this tree should guide you. Take note, sometimes we collapse these two, whole numbers and natural numbers. We treat them as the same. The only difference is that all natural numbers are whole numbers, but whole numbers, sometimes it's interpreted to contain zero. Natural number does not contain zero. Natural number starts with 1. 1, 2, 3, ... This one is 0, 1, 2, 3, ... Now if you come to integer starts with negative numbers. So let's say from somewhere at infinity, ... Negative, let's say 2, negative 1, 0, 1, 2, 3, ... Then rational number. All these numbers are rational because they can be written. All this number you are seeing here as whole number on their own can be written as over 1, over 1, over 1. So you can write them in fraction form. Hence, they are what? Rational numbers. Now, if you come to rational number on its own, what about numbers that can be written in fraction form, but they won't give you whole number? Like I said, every number here, integer, whole number, natural number, they are all rational. Added to rational now, let me say plus, all these ones under, then plus, you have concept of, let's say, 2 over 3, 1 over 5, 9 over, let's say, 7, continuously. These are rational numbers because they are written in fraction form. Irrational is a different thing entirely. E is an irrational number, pi is an irrational number, then surds are irrational numbers. So take note of this tree. All these ones, this is a subset of this, this is a subset of this, this is a subset of this and this are subsets of this. Irrational has nothing to do with the numbers here. Are you following, right? Yeah. So the number under is smaller than the one on top. So remember this formula. Larger number, union, smaller number will give you the larger number. And then smaller number, intersection, larger number, or larger number, intersection, smaller number will always produce that smaller number for you. This would be your guide in blasting any question given to you on the types of numbers and questions on types of number. That is number system is sure. Almost all of you will see questions on it. So take that lesson. I wish all of you the best. Like I said, see you next. Good night.